Hello again, it's Mr. Doro. Today we're going to be talking about mass-to-mass stoichiometry. We've talked about several different types of stoichiometry problems. This one's probably the most common, and it is going from mass of one substance to mass of another substance using a proper action line. Like I said, this is the most common type of problem in stoichiometry, and this is where you're going to be given the mass of one substance, we'll call it X, and you're asked to find the mass of another substance. Now you can go from a reactant to a product, from a reactant to another reactant, a product to a product, or a product to a reactant. It doesn't really matter as long as you have the balanced equation. So I want you to write down this generic form of how the action line is going to go. You're going to start out your action line with what you're given, which is the mass of X. We're going to call it grams because grams is the mass. Going to copy down in the next one grams of X, and then we're going to change it over to moles of X. Whenever we're given anything besides moles in stoichiometry, we got to get to moles. Then we're going to use that moles of X, change it to moles of Y, and then continue on in our action line, moles of Y down here to grams of Y. Now remember, you're given this part right here at the very beginning. This is your molar mass, and this is going to be 1 mole up here. This you get from the balanced chemical equations. You just copy down the coefficients for X and for Y. And then you're going to change your Y over to moles, from moles of Y to grams of Y using the molar mass. So we might want to write in here that this is molar mass. That's mm, molar mass. You should write molar mass in your notes. This is molar mass up here. These are going to be ones. These right here are going to be from balanced equation. That should be in your notes so that you know where to find it. And of course, this is what you're given at the very beginning back here. You're given whatever mass. So we're going to start with this problem that we have down here. How many grams of oxygen are needed to react with sufficient amounts of propane to produce 193 grams of carbon dioxide? I'm going to write out the balanced equation right now. Alright, so here's my skeleton equation. C3H8 is propane, and so in order to balance this, I'm going to put a 3 right here in front of the CO2. I need 8 oxygen, so I'm going to put a 4 right over here, and that makes 10 total oxygens on the product side. That means I need to put a 5 right here on this side. Now, the question is asking us how many grams of oxygen. That's what we want to find. That's like this, mass of Y. Y is our oxygen in this case. So, and it says to produce 193 grams of carbon dioxide. This is what we're given. This is our mass of X. So everywhere there's X up here, that's going to be our carbon dioxide. So we're going to go ahead and go through this one. So we're going to start out with what we're given, which is 193 grams CO2. Write the CO2 in there. Down here, we're going to put grams of CO2 to moles of CO2. We're going to change that over. This is 1 mole. This is the molar mass, which is 44.01. You don't know how to find molar mass? Check out an earlier video. And then grams of CO2 cancel out. Then I have moles of CO2 down here. Now I can go anywhere I want to on this balanced equation right up here. And I want to get to grams of oxygen. I can't go to grams of oxygen now. I have to go use a mole to mole ratio. A big mistake that people make is they'll put the grams of CO2 and then they'll put moles of whatever they want to find here. We have to stay with CO2 the whole time until we get to our mole to mole ratio. So back to our mole to mole ratio, we want to go to moles of oxygen. That's what it's asking us to find. It's actually asking us to find grams of oxygen, but we got to go to moles first. We're following our action line steps here. This I get from the balanced equation. In front of the O2 is a 5 up here in the balanced equation. In front of the CO2 is a 3. It's just like copying. Copy it down right there. And then we continue on. And then now moles of CO2 are gone. I want to get to grams of O2, and so here's my moles of O2, and now I can change that over to grams of O2 using the molar mass from the periodic table, and that is O times 2, which is 32.00. And then I multiply everything on top, starting with this number, multiply everything on top, hit that divide button for everything on bottom. You plug it in and see if you get the same answer I get. Okay, if you're plugging in your calculator right now, push pause so that you don't see my answer here. In 3 sig figs, my answer is 234, or 2.34 times 10 to the second. This is grams of O2. Everything else canceled out. I'm left with grams of O2 right up here on top. That's a mass-to-mass stoichiometry problem. Okay, now here's a practice problem where it's giving you grams, which is mass, of oxygen, and it's asking you to find how many grams of each reactant and the other product. It's actually 3 action lines, but these are mass-to-mass problems. So here's what you need to do. You need to pause this, and in order to get better at this, you need to write out the equation and then balance it. Go ahead and pause it now. And here is the skeleton equation. Now in order to balance this, I need to make my oxygens correct. So I'm going to put 2 right there, which then changes my magnesiums, and then also changes my fluorines. So I need 2's all the way across, can't reduce that anymore. So now each of these action lines, we're starting out, we want to end up with 29.6 grams of this O2 right here. And so we're going to do separate action lines, one of them going to MgF2, all starting with this, one going here, one going here, and one going here. And so they all are going to start out with 29.6 grams of O2. So I'm going to get those started right now. Now, obviously, I would suggest doing these one at a time. I just wanted to get them all started to see that so that you could see they're all going to start with the same thing. And they're all going to go changing from grams of O2 to moles of O2. We got to get to moles right away. And then we're going to go from moles of O2. This is where it's going to get different each time. So I'm going to finish in these other ones right now. Okay, now I use the molar mass each time right down here, 32.00 grams of O2 for every 1 mole. And now this is where it's going to get different. So as I go through, between the 3 of these, as I go through here, O2 has in front of it nothing, and so that is an understood 1 each time. So I'm going to put a 1 in front of each one of these. But then I'm going to change to moles of MgF2, and that one has a 2 in front of it, so from the balanced equation. And then now I'm switched over to, now O2 is done. Now I'm going to go from moles of MgF2 to grams of MgF2. And 1 mole, that has nothing to do with the balanced equation. This is a molar mass, and then I plug it in for MgF2 from the periodic table. And I got 62.31 grams. And so now everything cancels out except for grams of MgF2. Now I can plug this whole thing in right here and start out with what I'm given. Hit the divide button for everything on bottom, hit the multiply button for everything on top, and then we're going to see what we get. I got 115.2735 in 3 sig figs, and in scientific notation, that answer is going to be 1.15 times 10 to the second grams of MgF2, and then I put a box around that. Now here's what I want you to do. I want you to finish these other 2 right down here, and I'm going to give you the answer to see if you get it right, but you finish them up. I don't know which order you did these in, but I got 70.3 grams of F2 when I did that one, 74.6 grams of MgO. So if you're not getting those right, then go back and check out this example right up here. Check out the other examples. Get them so they're plugged in correctly. Check your molar mass first. A lot of times that's where students go wrong, the molar mass. This is a little visual map to help you see what we're doing here each time. In this case, we're starting with mass. This is our given. This is what we're asked to find. And so we're going from mass. We have to go to moles. Then we use the mole ratio. Change it back to moles. We're using those moles from the mole ratio to go back to mass. And so we're taking this pathway right here. You could do the same thing with volume, and you could do the same thing with molar concentration. But right now, we're concentrating on mass to moles, use the mole ratio, then change those moles back to mass again. Alright, I want you to try this problem. Notice it's giving you grams of iron and wants to know how many grams of iron 3 oxide. That's this stuff right here. This is a skeleton equation. Balance the equation first, then start out your action line. Follow those steps from before. And the answer that you should get for this is 28.6 grams of Fe2O3. And now if you're not getting that answer, then you might want to check your molar mass for Fe2O3. The molar mass should be 159.70 grams. If you got that molar mass and you're still getting it wrong, make sure that you're only using the coefficients in the mole to mole ratio. Anytime you're going from grams to moles or moles to grams, you should be putting a 1 in front of the moles and then the molar mass on there. And one more problem that I'd like you to do, it's got 2 parts, and these are mass to mass also. 9.3 grams of aluminum is what you're going to start each one with, and I want to know how many grams of each product there are. Make sure you change grams to moles for aluminum, then you can switch over to each one of these and then change them back to grams. And don't forget to balance the equation. It makes it very important when you're doing that mole to mole ratio. And the answers that you should get for this are 46 grams, that's in 2 sig figs, of the AlCl3, and 33 grams of the copper. Now, if you're not getting those answers, then you want to check your molar masses. You want to check and also make sure that you have the equation balanced, and you only use those coefficients when you're doing the mole ratio. Any other time, remember, you're going from grams to moles or moles to grams in a conversion factor, you put a 1 in front of the moles. Now, the only added bonus I want to show you is this. You could figure out the number of grams of copper 2 chloride because this is your total mass right here of the products. And remember, the law of conservation of mass says the mass of the reactants has to equal the mass of the products. So if you want to figure out copper 2 chloride, add up this total mass and subtract from that 9.3 grams, and that should give you how much copper 2 chloride had to react, as long as you get these answers correct. Or you could always just do another action line starting with 9.3 grams of aluminum and just go to copper 2 chloride. I hope this helps. Have a great night.